Developing and drafting a pWPS. Gary A. Pace, PE, CWI, welding engineer, Katy, Texas.
Learning objectives. In this module, we're going to talk about what is a pWPS. I didn't run into these until later on in my career when I got when I got involved in the oil and gas industry, and these are a little more prevalent, but it's a pre-WPS. And I'm going to explain what exactly this is in this module and kind of some theories on it. What is a pWPS and why do we need one? Well, a pWPS is a set of work instructions for the qualification of a PQR, a procedure qualification record. So when we're doing a procedure qualification record, we need to weld up a test plate. And odds are a welder's going to be doing that. So we need to have written instructions for that individual. Well, a pWPS, you really won't see this in a lot of codes. Usually where you run across it is in a client requirement or a contractual requirement or a specification from a client where they want to see that there are grown-ups that know how to qualify a WPS, how to do a procedure qualification test record correctly. So they will include this. So they have a pWPS. Many times, like I said, a pWPS is just going to be a customer requirement. They're going to want to see what you're going to weld before you do it. They'll have one of their subject matter experts say, yeah, this welding procedure that you're going to attempt, you're going to try and weld this test coupon with these variables, essential variables, and these parameters. This should work. That they're going to review it and say yes or no. That's where we're going to go with this. So the path of a pWPS. Well, we start with the engineer. The engineer calls some friends, does some reading, does a bunch of research, and they figure out what's going on the WPS, the pWPS. This is the work instructions for the welder to weld out the test coupon. So they write up this pWPS, the engineer does. Well, then they give it to the welder or the organization that is going to be qualifying the test coupon. And then the welder welds out the test coupon. And then we'll send it to a lab. But we'll get into that later on when we talk about PQRs. And the thing that we need to remember is with a pWPS, this is work instructions for the test plate only. We don't use this for construction or manufacturing or anything else. This is a one-trick pony. We weld the test coupon with it, and then we're done with this document. So this is the path and the life cycle of a pWPS. So a pWPS welding specification, like I said, it contains the required variables of the welding procedure to be qualified. So we're giving instructions to the welder that is going to weld up our test coupon. And depending on the client, you might need to get approval from them. I've worked down in oil and gas where nothing happened until that client, the customer, until their representative signed off on the pWPS and said, yeah, it looks like you guys are grown-ups. You guys can get this going. When you do need client approval, you send the pWPS off to the client to review. Their welding gurus are going to look at it and tell you either yes or no. And a lot of times in oil and gas where you might not have a lot of material to experiment around with what's going on, maybe you got one shot at this, a pWPS is a really good idea. And that's why they do it, to make sure you don't blow through that a long lead item, a long lead time piece of material that might take you 6 months to get. So that's one of the other driving forces behind a pWPS. Yeah, and maybe more or less you're just given a recipe for the test plate, and you're your guy is going to weld it, and like I said, the client, their welding engineer is going to take a look and at your plan and either give you the heads up or the thumbs up or the nope, you got to go back and figure out how you're going to do this again. And once again, it's not always required. It's not a code requirement. It's specified in some standards, and it can save a lot of heartache sometimes by ensuring that your client is happy. But it depends on who you're working for and what code you're working to. So the pWPS, as I said, is just the recipe for the test coupon. It is the work instructions telling the welder how to weld up that test coupon. So what information are we going to put on our pWPS? Well, we're going to put our base material. What's our base material that we're welding up? What kind of test coupon are we doing? Then we're going to figure out, okay, what filler material and what welding process are we going to use? This would be important information that we'd like to relay onto the welder. Are you welding this up with stick welding or TIG or flux core? What do we got going on here? We're going to give them some parameters like voltage and amperage. We're going to give them, probably a range. We're not going to let them go hog wild, but we're going to look at the manufacturer's recommendation for the filler material we're going to use, and we're going to provide that information to them and give them a starting point. We're also going to throw on there, hey, does this material need to be preheated and post-weld heat treated and whatnot? So, but we're going to dig this information out of our welding code and figure out, what essential and non-essential and supplementary essential variables are going to be required for the WPS. So for this one, for the pWPS, we're just going to look at essential and supplementary essential if required. So, but yeah, this is what information we're going to include because we got to give the welder a starting point. Hey, I want you to weld this metal with this filler material, this heat, this voltage and amperage. What can we do? So that's how we do this. Okay, so just a little bit of general methodology on this pWPS thing and how it ties into a PQR. So just kind of give you a little general idea. When you got to do a PQR and to support a WPS, this is kind of where we're going. But to do a WPS, you're going to need a pWPS. So first thing, find out what code you're working to. D11, ASME Section 9, D1.3, whatever. Figure out what welding code you're going to work to. And then figure out if there's any other additional requirements being imposed by the customers. Throw that in there. What welding process are you going to use? Stick, flux core, TIG welding? What do you got going on? Figure that out. And then, make sure the base material that is called out by the customer matches the code you're going to be working for. You're not going to do a stainless steel weld to a AWS D11, which is a structural welding code. So make sure everything matches up. Oh, here's the one you want to do too is play to your strengths. Make sure that you're qualifying the procedure. You're setting up your pWPS and your procedure for a welding process that your shop's proficient with. Years ago, I worked with a guy and we were in a welding shop and I was like, why don't we stick weld this? This would just be easy to knock out. And he's like, we don't stick weld. We do gas tungsten arc welding, TIG welding, and we do submerged arc welding. That's it. Anything else is just, we'll F it up. It will be a mess. So that's why we do this. So most shops, in my experience, have one or two welding processes that they're really good with. So, my general idea is play to your strengths unless, you are forced to do otherwise. But, whatever you do proficiently, kind of stick with that. And if you got to venture outside of that one, okay, do it, but do a little research and get everything put together correctly.
So anytime you're doing a pWPS, there's some questions you need to ask yourself when you're putting together your pWPS. Because a pWPS, as I've stated, is not a code requirement. So a lot of times you're going to be out there running on the ragged edge. And by the ragged edge, I mean you might be doing something that your company hasn't done before. So you need to ask some questions. Does this make sense? Does the work process from the lens of common sense um, make sense? Do the base material specifications, what we're welding together, make sense? Is the thickness or the diameter of the pipe, does this make sense? Are the base metal, filler metal, and the combinations you've picked out, are they compatible? These are questions you need to ask yourself.
So after you've decided what process you're going to use, then and which welding code, you're going to dive into the welding code and figure out what essential variables are needed. This is what you're going to put on the PQR. This is also what's going to be addressed, what you're going to give. You're going to provide these essential variables and instructions to your welder in the form of the pWPS, the pre-welding procedure specification, the work instruction for the weld test coupon. And you're probably going to want to throw on some non-essential variables that need to be addressed also. You're going to try and provide them some instructions, such as cleaning, filler metal sizes, that type of stuff. For ASME Section 9, you're going to want to look on the tables in QW 200, and I think they start at QW 253. So this will give you the relevant essential, supplementary essential, and non-essential variables. D11, they're going to have the structural steel welding code. It's going to have its own essential variables, and all other codes we're going to have some essential variables, their own essential variables. And just keep in mind that just because something's an essential variable in one code doesn't mean that it's an essential variable in all the welding codes. So that's something to be cognizant of.
And then you're going to have some sources for parameter information. I get this question all the time. Hey, where do I find my parameters that I'm going to give my welders to work with when they're welding this stuff together? Well, when you're putting together your pWPS, and even when you're writing your WPS later on, some of the books that I've used in the past are like the Procedure Handbook of Arc Welding. This is by Lincoln. And the Welding Handbook. This is by ESOB. A lot of these manufacturers have books like this, publications like this. You can get a lot of them online anymore in PDF form, but they have a lot of information in them that you can use to put together your game plan on how your guy is going to weld up this test plate, because that's what we're doing with a pWPS. We're going to weld up a test plate, and we got to give work instructions to our welder to weld up a test plate. Another question that often gets asked, hey, how do I know if I can weld these materials together? Well, some of it is just common sense. Maybe some of it is not so common sense. But here would be an example of, a P1 material, your garden variety carbon steel, being welded to a 9% chrome, these P15E materials. These things are nasty to weld. They've got preheats up to 400 degrees. The post-weld heat treatment's 1350 to 1400, which if you weld carbon steel to that and you post-weld heat treat your garden variety carbon steel at that temperature, it's going to turn to mush. You're going to destroy the the mechanical properties of that carbon steel. So these are some things that you need to be cognizant of. And there's no one source. Sometimes it takes years to accumulate this knowledge. Hey man, this isn't a good idea. And it requires reading and acquisition of some information. And like the previous slide, the boiler and pressure vessel code, we've got P numbers that tell us what the different groups of material are, but some things you just can't weld together with arc welding. Carbon steel and aluminum doesn't work. You can arc weld both of them, but welding them together just does not work. Metallurgically, not going to happen. So these are things that you need to know, and this is an extreme example, but just kind of giving you an idea of things you need to look at when you're putting together your pWPS.
So here would be an example of a welding procedure specification, a WPS. I would just use the same form and make sure that everybody knows that this thing is a pWPS. And I'd write that on there. Not for use in production, maybe throw a watermark on it. Just let everybody know that we're welding up this test coupon. I wouldn't print a lot of copies of this so that it's floating around on the shop floor, but you're just going to write some numbers in that make sense into your pWPS form. We're going to talk about tolerance ranges. We're going to give the welder a groove type, some joint details, probably throw in some post-weld heat treatment or preheat ranges. Then we're going to, what's the filler metal we're going to use? How many weld layers? All of that kind of information. You're definitely going to give them the filler metal type and the preheat information so that they have a starting point. So on our pWPS, you're probably also going to want to give the welder a range of what they're going to do with their voltage and with their amperage. The current type and polarity. You don't want to just throw those guys to the wolves and then have them figure it out. You're probably going to want to dig through some customer literature, and find some recommended voltage and amperages for their product line. Most material manufacturers, the Lincoln Electrics, the ESOBs, and other filler material manufacturers will give you a general idea and a range of volts and amps that you need to utilize to properly deposit their filler metal into a weld joint. So, but you're going to provide this information to the welder and then let them fine tune it. Get what it exactly needs to be. I would also throw in information on, a stringer or a weave, and a lot of this might not apply to every process, but I would, throw this information in there on how you want it done. Inner pass cleaning. Okay, we want it cleaning between the passes. I want you to use a wire brush. I want to use a wire wheel. I want you to use only a chipping hammer, whatever. But you can see what we've got going on here, where you just generally want to give the welder some information. So it gets back to why are written instructions important? Well, purpose of written instructions is we're trying to communicate with the welder and give them an accurate picture of what we want as a product from them. And the welding foreman or whoever's going to be performing this work task of qualifying welding up our procedure qualification test record, test plate, we want them to do it properly. We want them to follow our instructions. We don't want them going off the rails on us. Don't assume just because you know what you need to be done that everyone on your team has the same level of understanding. That's why I'm a big proponent of work instructions. I know it's tedious and brutal, but a lot of times when you do these, you can copy and paste them over, these work instructions. So that's kind of how I run my universe when I have welders. So here are some examples of a work instruction. A standard WPS form a lot of times isn't going to be able to contain all the instructions and information required for doing a PQR. So when you do a pWPS, maybe you got to do a little sketch like this one, and then it allows the welders to know what's going on. And if you're interested, I can send you down some roads to find some drawing packages that can put this kind of stuff together for pretty cheap. But this was a 8-inch thick test block. This is the arc gouging instructions. This is how I want them to prepare the weld test joint. Work and supplemental instructions bridge the gap between what can go on a WPS and what sometimes we need in the local environment. Work instructions generally contain certain tasks or setup like this one. It's to gouge out the weld test groove that we were going to utilize. And I usually do them in Word or PowerPoint, write them up. And then any sketches I do in LibreOffice or on Google Draw. So here might be an example of a work instruction, okay. In that lower portion, it tells us how to prepare the coupon. How are we going to do this test coupon? So that's something that we need to keep in mind is, hey, we're trying to communicate to the welder. I want this, 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 and this done. So, also, I got a buddy, he gives instructions for whoever's recording the parameters. So he gets down and dirty with his pWPSs in regard to providing very detailed instructions on what he wants recorded, how to record it, what machines, how to approach this, where you don't have the person, recording just doing a garbage job. So sometimes you might give them a little table that explains travel speeds and whatnot, and it gives you the amps, the volts, all that kind of information, so that the welder, you're trying to set the welder up for success, so that you don't have to do this qualification test coupon, your PQR test coupon multiple times. And once you kind of built these work instructions, you're not going to have to redo a new one every time. You're probably going to be able to copy and paste and change some of the material on these. And another work instruction would be, letting them know how you want the weld beads stacked in there, and, keeping an eye on them. All right, for the summary, this one we talked about an explanation of a pWPS, a pre-welding procedure specification form. And this is the work instructions that we give to a welder or the welding foreman or the entity that's going to be performing our weld test coupon. And I gave you some examples and kind of gave some philosophy in regard to examples of work instructions and how they tie into what we're trying to accomplish. Questions? Give me a shout. Shoot me an email, Gary Pace, PE, CWI, Katy, Texas. There's my email address if you want to contact me. I'm pretty good about getting back to people if they got technical questions about metallurgy, chemistry, or welding.